Time in the morning is the purest, the most valuable, and the most productive. The morning is like the foundation of the house. If the foundation is weak, the entire building will collapse no matter how beautiful it is built. Why do I say this? Because in the early hours, your mind is fresh, your energy is strong, and the world is quiet. There are no distractions, no phone calls, no noise, no chaos. It is just you in your thoughts. This is the time when you can think deeply, plan carefully, and prepare yourself for the better future. And here, coming to the point, and here is the last topic from the statistics, that is chi-square test for population variance. Suppose the random sample, see here, suppose the random sample is drawn from the normal population with mean mu and variance sigma square. Now, to test the hypothesis that the population variance is sigma square has a specified value, that is a sigma naught. So as usual, we have to go with the 5 steps. The first one is the null hypothesis. Sigma square is equal to sigma naught square. Alternate hypothesis, sigma square not equals sigma naught square. Test statistics, and here is the formula, that is chi square is equal to ns square by sigma naught square. So here is a specified value, that is a sigma naught square. And as usual here, sample variance S square is equal to the sample variance, and here n is the sample size. And assuming that H naught is true, the test statistics chi square follows the chi square distribution with n minus 1 degrees of freedom. So here is the conclusion part. So if the calculated value is greater than the tabular value, we reject the null hypothesis H naught. Otherwise, we accept the null hypothesis. And here are the 5 steps. First one is null hypothesis, alternate hypothesis, test statistics, degrees of freedom, and the conclusion. And here are 2 examples from the textbook. So the first one is a random sample of size here is 20 from the normal population gives a mean of, see here, the mean value here is 42 and the variance here is 25. And now we have to test. Now we have to test that the population standard deviation is 8 at 5% level of significance. So here the data is given, the sample size is given as 20, the mean value is given as 42 and the variance is given as 25. And we have to test the hypothesis that the population standard deviation is 8 at 5% level of significance. See here, the sample size is 20, x bar is equal to mean is equal to 42 and s square is equal to 25. As usual, we have to go with 5 steps. The first step here is the null hypothesis, sigma is equal to sigma naught is equal to 8. Alternate hypothesis, sigma naught equals 8. Here is the test statistics. So here is the formula, very important, when the mean and the variance are given. That is chi square is equal to n s square by sigma naught square. So what is n here? 20. What is s square? That is sample variance s square is equal to 25 by sigma naught square. So here sigma naught is given as 8, which is equal to 8 square. The value when after calculated through calci, this is a 7.8125. Clear? So this is the formula. So these are the 3 steps here: null hypothesis, alternate hypothesis, and test statistics. And next one here, chi square we got as, see here, this is the calculated value, that is a 7.8125. And now we have to go with the degrees of freedom, that is n minus 1. So what is n here? 20. 20 minus 1 is 19 here. So we have to go with the table. So here is the chi square table here. So this is the chi-square table here. The degrees of freedom is 19. So we have to go with the 19 at 0.05 level of significance. That is, see here, at 19, 0.05 level of significance is 30.144. See here, from the table we have at 5% level of significance at 19 degrees of freedom, we have 30.144. So here is very clear from the table here. So at 19, at 5%, that is 30.144 is the value. So this is the this is the tabular value and this is the calculated value. This is a 7.8125 is the calculated value and this is the tabular value, the tabulated value. So here it is very clear that the calculated value is less than the tabular value and therefore we are going to accept. So we are going to accept the null hypothesis H naught, and therefore the conclusion that the population standard deviation 8 at 5% level of at 5% level at 19 degrees of freedom. So we conclude that the population deviation is 8. The value here is 8 is accepted at 5%. level of significance at 19 degrees of freedom. So this is the steps we have to take. So this is very, very important. Chi square is equal to n s square by sigma naught square. So here n is sample size, s square is the sample variance, and here standard deviation sigma naught square is the specified standard deviation. And here is one more question here. So this is also, please note that it is very, very important. So this will be repeatedly asked a question. So here a firm manufacturing reverts wants to limit variations in their length as much as possible. The lengths of 10 rivets manufactured by the new process are, so these are the 10 values, that is 2.15, 1.99, 2.05, this is 2.12, 2.17, 2.01, 1.98, 2.03, 2.25 and 1.93. So examine. So we have to examine whether the new process can be considered superior to the old if the old population has a standard deviation. So here we have to note that the standard deviation value is given as 0.145 centimeters. And now we are going to calculate the mean and S square. So here for calculating the mean, the data is given as 1.25 till 1.93. So here, so these are all the x values, so which I have taken, that is 2.15 from this. So this is 1.99, 2.05, that is 2.12. So here, so this is the total value of the mean. So here how many number of values are there? 10 rivets. So here n value is equal to 10, and therefore after totaling all these values, x values, after you make a total, so this is 20.98. So n is equal to 10 here, therefore x bar is equal to sigma x by n. What is sigma x? So this is 20.68 by 10, the value here is 2.068. So this is nothing but the x bar value. So here in the next column, x minus x bar. So we have to subtract each and every x value from, this is 2 point, so this is x minus, this is 2.068. so here this is 2.15 minus 2.068 is 0.082, that is 1.99 minus, this is 2.068 is minus 0.078, that is 2.05 minus 2.068 is this one. So we have to fill this column using your calci, and here is the next column, that is x minus x bar whole square. So we have to make the squares out of this. So using your calci, if you make a squares, so this will be the total, and therefore s square is equal to sigma x minus xi bar whole square by n. So here is the total, that is 0.09096 divided by 10. The value here is 0.009096. So it is the round figure, and therefore for the test statistics, chi square is equal to n s square by sigma naught square. What is n here? 10 rivets, the n is equal to 10. S square, so s square value is very clear as 0.009096 divided by sigma naught square. So here is the special standard deviation here, that is standard deviation is equal to 0.145 is the value, and therefore we are going to substitute here, that is 0.145 whole square. The value chi square is equal to 4.32 and 62. 3262 is the chi square value. So here the value here, that is sigma naught square, is taken from the textbook, and this is the x value. So just now I have shown you how we have got. And here every time we have to take the 5 steps. The first one is the null hypothesis, sigma square is equal to sigma naught square. Alternate hypothesis, sigma square greater than sigma naught square, and level of significance is 0.05, and assuming h naught to be true, the test statistics here is the value here is chi square value is equal to n s square by sigma naught square. So n value is equal to 10. So here I have shown you the calculation part of this one is, this value is 10 into 0.009096. So we got 0.0096 from this table. So here is the table. First one is x minus x bar whole square. So after calculating, so we got s square as 0.09096 by 10. The value here is 0.009096 into 10 divided by 0.145 whole square. The value here is 4.3262. So here 3260 is the value. So here is the calculated value, chi square is equal to, that is after taking the round figure, that is 4.8. So at degrees of freedom, so n is equal to 10. Degrees of freedom is n minus 1, that is 10 minus 1, 9. So at 9 degrees of freedom, so we have to check this table here. So this is the chi-square table. We have to go with 9 at 0.05 level. That is a 16.919. 16.919 is the value table value. And see, if you observe the table value at 9 degrees of freedom at 5% level is a 16.919. And since the calculated value is less than. So what is the calculated value? This is 4.326. And here a tabular value is 16.919. Clearly the calculated value is less than the tabular value, and therefore we are going to accept the null hypothesis H naught. So here we are going to accept the null hypothesis as the calculated value is less than the tabular value, and therefore the new process cannot be considered superior to the old process. And this is the final conclusion. So here are the review questions, and here are the few questions, and this is the end of the statistics. And these are chi-square test of goodness, the 3 models I have taught you. And in my next video, I'm going to upload each and every formula. Thank you so much for watching, and this will be uploaded in the playlist. So many videos are uploaded. The whole textbook is in the playlist. And see, if you really like this video, here is the help I need from you. That is, please pass it on to as many friends as you can. That is the greatest help needed from your side. Thank you so much for staying till the end.